When you fail your ESE 111 final, you go out. And when you go out, you party. And when you go out and party, you get drunk. And when you get drunk, you want to sleep it off, so you go back home. And when you go back home, you have to enter your PIN code. And when you can't enter your PIN code, you get murdered. Don't get murdered, get pin-faced.
We have developed PinFaced, an apparatus that finds out your PIN code and enters it in for you, so you don't have to do it yourself. How PinFaced works? There are solenoids that fire off in a distinct pattern that matches your PIN code, based on a pre-existing number that's sent to PinFaced. That solves all of your issues. You get in, you don't get murdered, and you have a good night.
Whenever you're ready. So when an average person walks up to a pin, they're going to swipe their card. And in this case, my pin is 1638. So I would go ahead and push 1, 6, 3, 8. And what do you know? It's a match. Now, when somebody can't put in that pin, what they're going to do is they will then swipe their card. That pin, 1638, then gets sent to PinFaced. They set PinFaced over the card reader. And if you can look on the left, you can actually see the numbers appearing. 1638, it's a match.
Now, we're going to give you a technical explanation of how PinFaced works. Specifically, there are two main components. There's the keypad component, which we built because we couldn't get access to an actual keypad, and then there's PinFaced, which is the component that's on top that is slid over the keypad in order to enter in one's PIN. So first, I'm going to explain the keypad and how the keypad works, and then I'm going to talk about how PinFaced works, then I'm going to talk about how the two work together. This is the PinFaced keypad. It contains a number keypad, and it contains a magnetic card reader as well as LED indicators to know when you have when you're entering numbers, as well as when you have a match with the specific PIN number. The magnetic card reader just takes information from any card, whether it's a pen card, credit card, and it enters it into a computer in the form of a keyboard. The way that we have the keypad wired is it is wired to a computer, and specifically the cursor is placed on the input section of a serial monitor of an Arduino. When we have it, when we swipe a card, there's a stream of text in the input monitor, which the Arduino can then read, and I'll explain that later. Here is the keypad. The keypad is a stripped version of an Arduino keypad, and as you can see here, we've soldered the individual pins and wires from the keypad to the Arduino below, which I'll show you. But basically the way that the keypad works is there is a grid, and when a button is pushed, what's actually happening is that a specific row and a specific column are shorted, and that's read by a digital pin in the Arduino. And lastly, you can see that those are just simple LEDs which are connected to our Arduino. So I can show you what we've got under the hood here. We've got an Arduino Uno with a SparkFun breadboard. We can't remove it right now because it would interfere with the keypad wires and there might be a disconnection. But as you can see here, there is a Bluetooth module as well. Specifically, this is the master Bluetooth module, which will send information to pin-faced. That is hooked up to pins 10 and 11 on the SparkFun board. Each of the pins on the keypad is connected to pins 2 through 9 on the SparkFun keyboard, and the LEDs are connected on the breadboard with a resistor in order to prevent overheating by the LED. So that is the keypad. This box is usually covered.
No, I say we cut this off.
And the keypad lays flat, and we place the pin-faced module over it. So before we move on, I want to explain how the code works for the keypad. First, there's the component that takes in the pen ID from your pen card, and that input occurs from the magnetic card reader to the computer. We have built into our code a section that parses out the exact positions in which there is the pen key, the 8 digits of the pen key. We just counted, it's the same exact location for any pen card. So this product can be reused on a number of, actually an infinite number of pen cards. Additionally, we had to program the keypad to the Arduino so that each key and each number was registered as a specific value on the computer or on the Arduino itself. What's happening is when you push a key, it builds a string of four numbers, which you can see in our demo, and it does this just by adding to a string each of the characters that are passed from the keypad to the Arduino. And then we take that string of 4, we send it to the pin-faced Arduino via Bluetooth, just a simple Bluetooth connection. How do we get this pin from the pen card? We've built a just a kind of map in Arduino which links one pen key to one pin number. Lastly, the last component of the code is the LED. The way the LED works is every time that digit is pushed, the yellow LED blinks off and then back on. So its constant position, its normal position is on, and the green LED turns on when there's a match. So when the 4 digits that are entered match the 4 digits that the Arduino is looking for, the green LED turns on. Okay, here we have the pin-faced apparatus. This apparatus goes on top of the keypad, and it contains 2 layers. The first layer contains the solenoids, which push down on the keypad itself, and then the second layer contains 2 Arduinos. I'll talk about the second layer, and then I'll talk about the third layer. When I talk about the third layer, I'll explain why there are 2 Arduinos, I'll talk about the Bluetooth module, and the code. So, this empty space right here, that's where the keypad goes. I'll just slide this box over the keypad. Okay, the second layer contains 10 distinct solenoids that are controlled by this proto board here. We've soldered all the different components. This protoboard contains 10 circuits. Each circuit consists of a transistor, resistor, diode, and each little mini circuit controls one solenoid. The way that the circuit works, or the way that a circuit works of these 10, is the transistor receives voltage from a digital pin that's connected to the gate of the transistor, and depending on the voltage, whether there's high voltage or low voltage, the transistor switch is open or closed. In its natural position, it's open, so there's no power coming from an external source. But when the digital pin is high and the switch is closed in the transistor, the solenoid is able to draw power from an external power source, such as this power source is triple output 6-volt DC power supply. No, not 6 volts, it's more than 6 volts, but we use it at 6 volts. Then we've got part of this one mini circuit in the source column, which is the third column of the transistor. There's just one pin taking the source back to ground to complete that circuit. And in the drain, which is the second column of the transistor, there's a diode that prevents back voltage from the solenoid, or back EMF from the solenoid to the Arduino board that prevents it from frying in. Then we've got two cables, one from power, one from the drain, that are connected to the solenoid. The way that the solenoid works is fairly simple. When there is current supplied to the solenoid, there's a wire that wraps around a piston-like metal bar in the solenoid. And when there's current supplied, there's a magnetic field that's created which pulls down the metal bar and then pulls it, and then the bar is released back to normal when the current is stopped. In order to create the current, that's why we have an external power supply. The external power supply can it supplies about 500 milliamps of current, whereas the maximum amount of current that the board can supply, the Arduino board can supply, is only 40 milliamps, which is not nearly enough current that the solenoid requires. So we have this transistor, this electrical switch, and an external power supply to give it 10 times the amount of current, so that there's enough power and enough power that goes to the solenoid. Okay, now each of these circuits is controlled by a Arduino, just regular Arduino Uno, and as you can see here, there are pins connected to the digital pins of the Arduino that can create a high or low signal to the transistors. And then in pins 2 and 3, we've got the Bluetooth module that's connected. And again, as I explained before, the Bluetooth module is the receiver for the information that's sent from the keypad to the pin face device. The keypad is sending in a 4-digit integer, and it sends all of that together, and that's the specific pin that it parses from your pen ID, sends it to the pin face apparatus, and the pin face apparatus in the code for this main Arduino that controls the solenoid, we've made it so that we're able to parse through and isolate each digit. By isolating each digit, we can decide which solenoid receives power just by deciding which of these digital pins is high or low. Okay, that takes care of the Arduino that controls the solenoids themselves, and the protoboard. Lastly, we can talk about the Ethernet capabilities and the Ethernet purpose of pin-faced. So the reason why we have to have two boards and not just one board with an Ethernet shield is because the Bluetooth and Ethernet interfere due to mutually exclusive use of pins on the Arduino board itself. So for that reason, we need a second Arduino that has Ethernet capabilities. when when the solenoids receive a pattern or receive an input of a pin, the Ethernet board can send an email to someone's account, Gmail account, any account, pen account, and can indicate to this person, hey, please pick me up, I've used PinFaced, help me go to sleep. What's unique about these two boards and these two devices is that they don't require a computer to be attached to the boards, because once we upload the code onto the boards, they don't need any additional computer processing. So we're able to have external battery packs that are connected by USB to these boards individually. However, because we're using an Ethernet board and wireless board for the purpose of this demonstration and demo, we need to have a wired Ethernet connection. Additionally, we need to have wired connection from this power supply to the solenoids. However, that can change later when we add another battery pack, for example. But just because these solenoids require a lot of power, we're going to use the external power supply. Okay, now that we've explained all layers of the pin-faced apparatus, and we've explained the keypad as well, now we can talk about how the two function together. Now that we've shown you how the pin-faced apparatus and keypad work individually, we can show you how they interact when they're together and kind of what enables that interaction. So we can slide this pin-faced apparatus over the keypad, as you would do if you're actually using pin-faced. And what you can see initially is that we've got each solenoid lined directly above a key, so that there are clear results when a solenoid is pressed, and these results are reproducible because the way that we've designed the outer casing is that it fits perfectly around this keypad. Now, while this keypad is not a real-life keypad that's used by school security, this is an example of how we can manufacture pin-faced to fit above a unique keypad. Now, the keypad and the outer casing for PinFace was developed on SolidWorks through our own kind of unique architecture, and it can be changed and modified for specific devices and uses, such as an ATM bank or for other schools' keypad entry and exit systems. So you've gotten a good look at how keypad works. We have the code uploaded on DevPost. You can take a look at the code. You can take a look at the SolidWorks files that show how PinFaced and the keypad were built, and you can now see how the technical aspects of PinFaced fit with the vision of PinFaced, which is getting kids safely into their home at universities and schools.